Direct variation means y varies directly with x. There's two ways you're going to see it. Y equals kx, or I could solve for k and divide both sides by x and get k equals y over x. Now, what we're going to do to find this is we are going to take y over x, and we're going to try these two first. This one first, which is 2 over 1. Then we'll do this one. Does that equal 6 over 3? Then we'll do this one. Does that equal 8 over 4? Well, that's 2, and that's 2. Hopefully what we noticed here, when we're all the same, that it has a direct variation or a constant of variation. Another way you might see it is constant of variation. Well, I know you've seen this, y equals mx plus b. If I asked you, what does this m represent? Hopefully you can tell me that's the slope. When I have a constant number, I have a constant slope. Therefore, k is just like my slope. Let's try another problem. Does this have a direct variation? Remember, direct variation is y over x. So this first one, I have 4 over 1, which equals 4. The second one, I have 8 over 2, which equals 4. So far, so good. The next one, I have 11 over 3, which equals 11 over 3. That does not equal the same thing, therefore there is no direct variation. The next problems might say identify the direct variation, or really truly we're identifying the slope. So for us to identify the slope, I have to solve for y. So this first problem, I'm going to divide both sides by 3, and I have y equals 7/3 x. There's my direct variation. The slope is 7/3. The next problem, I'm going to divide everything by 7. So I have y equals 2x plus 1. My slope is 2, which is my direct variation. The last one, we have a couple extra steps. So the first thing I'm going to do is I'm going to subtract 5x to the other side. So I have 3y equals negative 5x. Then I am going to divide both sides by 3. So y equals negative 5/3 x. My direct variation is the slope, which is negative 5/3.